Okay, so y'all plugging this into the quadratic formula? Do you know the quadratic formula? Oh, okay, that's good. Okay, so plugging it in, we say that A is 6, B is 6, and C is -3. So plugging it in, we say X is equal to -B, which is -6, plus or minus the square root of 36, is B squared, minus 4 times A, which is 6, times C, which is -3, all over 2 times 6. Okay, so let's see. I guess in between A and B, we're going to say -6 plus or minus. 4 times 6 is 24. Times 3 is that's 72. So we have the square root of 108 over 12. Okay, so the next step says simplify the radical. So I want you to simplify 108. Sure. Okay, so think about, oh, okay, do you know how to prime factor a number? Where you break it apart? Okay, so you grab a calculator and you say, oh, 108 is even. Or maybe, I was supposed to say 2 would work. But maybe I become a big spender and I try 4. So I say 108 divided by 4. And does that go in? Oh, it's 27. Anybody need a calculator? These calculators that you're allowed to use on the midterm. You can bring your own, absolutely. So if you're using your phone today, maybe that's not such a good idea, since you can't use your phone on Thursday. Well, you'll get an idea from the questions today. It'll be the same setup. Anybody else? A prime number is a number that has only itself and 1 as a factor. For instance, 13. 1 and 13 are the only factors of 13. 2 and 1 are the only factors of 2. 5, 7, 11, 17. Not 108, because it has 4 and 27. It's composed of other numbers, so we call it a composite number. Yeah, if it's a prime number, what am I going to do? Or if I can't find any pairs, I can't simplify it either. But look, I already have a pair of 2. So, pair of 2s. I have actually a pair of 3s plus an extra one. So these are coming out, and these are coming out. Okay? So, you don't have to do it this way. You can just kind of play around with your calculator. See how much you can take out. For instance, maybe you played around with the 2. I'm sorry. Oh yeah, maybe you played around with the 2 and the 3 and you thought, maybe 6, 6 times 6 times 3. Am I wrong? I think it's times 3. Yeah, of course it is times 3. And then you're like, oh, I have a pair of 6s. So you can do it that way too. Either way, a 6 is coming out. And the 3 is getting left behind. This 3 is getting left behind. One of these is coming out with the other one, that makes 6. So that kind of sort of clear. I feel like I'm making it work. Okay. All right. I'm sorry? Yeah, I mean, I could write it kind of in between. I could say, -6, plus and minus. There's a 2 that comes out, and there's a 3 that comes out. Because I have a pair of 2s, and I have a pair of 3s. And eventually I'm going to write 6 out there. But in the meantime, only the 3 is trapped inside. It has no pair. This third lonely 3 here is trapped inside because it can't. It needs a buddy to leave. Okay? These guys have buddies to leave. So simplifying it would look like this: -6 plus or minus the square of 6 times the square root of 3 over 12. Okay. So that's what I mean when I say simplify the radical. I want you to get it in the lowest term as possible, which then will lead you to cancel. Because before you couldn't say, oh, the 6 and the 12 cancel, because there's nothing here. There needs to be something in front of the radical for you to cancel. And there was nothing out there, but now there is. Okay, because you can't just cancel these, you also have to cancel this way. It's not just one direction. Okay, so let's see. If I do that, the 6s are all going to cancel because 12 has a 6 too, right? So I'm going to get -1 plus or minus the square root of 3 over 2. Do you see how I took all the 6s out? Kind of, sort of. Okay. Now I know that you could go straight from here down to the next step and get the decimal numbers. So if you do that, you lose a point, but I'm just saying, if you want the point for simplifying the radical, do this. If not, if you're like, I just can't remember that, that's too much. Okay, skip it, it's only 1 point. Oh, thanks. Okay, so it's not all or nothing. You get partial credit. So let's see, the decimal intercepts. All right, so I think it's easier if we split this up into 2 things. Okay, I'll let you go ahead and do that. Try to get 2 decimal intercepts from that so far, what we have now. Because it's hard to think in terms of fractions. He's back. So when I say decimals, I assume you're going to round to the 10th place, like 1.3 or something like that. Yeah. No. I like to separate them. You don't have to, but I like to. Well, it's 1 fraction over there, but then I make it 2 fractions. They both have the right to be over 2 independently. 2 is dividing into 1. It's also dividing into the square root of 3. So I can write them as 2, because I'm getting ready to change them to decimals. And since it represents 2 different problems, one's where I add and the other time when I subtract, I think it helps to think about them as 2 parts. Okay, so this is a calculator thing here. Let me grab the calculator. You got to make sure your calculator does this right, and that you know how to make it happen. Everybody else need a calculator like this? Yeah? I'm going to get more. Okay, so we know that 1/2 is 0.5. I mean, you can say 1 divided by 2, but it's going to be negative 0.5, right? And then square root of 3/2. That could be tricky on your calculator, so make sure you get this. I'll just say 3 square root. I put 3 and then square root on this calculator. And that gives me 1.73. And then I say divide by 2. And that gives me 0.866. And I'm just going to say plus or minus 0.9. Because I don't want to say 0.86. If you want to be real accurate, you can, but I'm okay with just the tenths place, 0.9. Does your calculator give you 0.9 when you say square root of 3 divided by 2? Make sure that it does. Some of you have that slightly more expensive Casio where you have to close the parenthesis before you. Oh, yeah, if you have this, you're probably set. 0.866, so you round up to 0.9. Yeah. Some of you have calculators where you have to close the parenthesis after the square root of 3 before you divide, or they think that you're doing this. And you're not, but you didn't close the parenthesis, so your calculator thinks you meant that. And you don't. You just mean the square root of 3, not the square root of 2, just 3. But if you don't close the parenthesis, then who knows? Okay, so just to be aware of that. All right, so here's what we have, and we're going to get the 2 decimal numbers. So when I say negative 0.5 plus 0.9, that's going to give me, what is that going to give me? 0. I can't write. 0.4 plus, and when I subtract, I'm going to get negative 1.4, right? Do you see how I got my 2 decimal answers? I added the 0.9, and then I subtracted the 0.9. Yeah, close enough is definitely good. Some of you maybe use more decimal places than I do, but you don't need to. Tenths is fine. Okay, so find the axis of symmetry. Go ahead and find the axis of symmetry. Okay, so make sure you practice that, Lynn, because. I'm sorry? Oh, okay. So the way we find it is we add these 2 values we just got together. So we say negative 1.4 plus 0.4, and we divide by 2. We're finding the average of 2 points, which is going to be right down the middle, the axis of symmetry. So we add them together and we divide by 2, just like we would if I said, I have 5 dogs, and you say, I have 7 dogs, and we add them together and we find out we have an average of 6 dogs. This is what we would do if we were wondering about the average. If we did it in here in the class, we'd be like, okay, how many dogs does each person have? And then we divide by 20. In this case, we're only dividing by 2 because we only have 2 points. Okay, so we have negative 1 divided, the axis of symmetry is 0.5, negative 0.5, negative 0.5. Okay, or negative 1/2, however you want to look at it. But since we were doing decimals, I figured I'd write it as a decimal. Okay, and now the vertex. Please find the vertex. And I'm just scrolling up here for no apparent reason. I'm just scrolling up here, just in case, you know, you want to see the top. Please find the vertex. Excellent. Look, I was going to say, it can't be the only thing if you can do this. Hmm. After that, you burn out and it's over. Do that. Everybody get what they need? I'm going to go right down. Are you finding the vertex? Oh, good, good. Did you see what you needed to see up here? Okay, good, good. So hopefully you're doing something like this. The function at negative 0.5, and you're plugging that in, you're saying 6 times negative 0.5 squared plus 6 times negative 0.5 minus 3. Okay? So 0.5 times 0.5 is 0.25, it's positive, and it's a quarter of 6. What's a quarter of 6? 1.5. 1.5 is a quarter of 6. So we get 1.5. If we do it on the calculator, we get 1.5. And then 6, half of 6, and it's negative, that's negative 3. And we have a negative 3 anyway. So now we have negative 4.5, is that right? So my vertex is at negative 4.5. I plug in the axis of symmetry. We've been doing this with angry sheep and all the whole thing, you know. We've been doing this for a while, so hopefully this feels familiar. I need the vertex, I plug in the axis of symmetry. Well, okay, let's see. 0.5 squared, that's 0.25, and then I multiply that by 6. And that's 1.5. A quarter of 6. So I split 6 into 4 pieces. 1.5, 1.5, 1.5, and 1.5 makes 6, right? So. That's an excellent question. That's an excellent question. I'm glad to emphasize that the only thing the exponent affects is the 0.5, the negative 0.5. It does not affect the 6 at all. PEMDAS says, take care of the exponent in the parentheses first and the 6's later. Please don't put those together before you take the second power. So yeah, square 0.5, negative 0.5 first, and then multiply by 6. Yep, PEMDAS is a big deal. It's our language. It's how we communicate. It's how we know what to do first. If we didn't have PEMDAS, we just have to assume what somebody meant. Oh, I don't know. What should I do first? Yeah, well, I mean, PEMDAS tells us the order. Otherwise, we just guess. Well, that would really be a zoo, wouldn't it, if we went from left to right? We need those rules. So.
I created it right now.
Well,
Way easier.
PEMDAS, I've done that my whole life, so I don't want to change that. I'm kind of resistant. It would really change a lot, and boy, I'm not sure it would be better. Okay, so we have to remember some things if we're going to graph this. So hopefully you're setting up your graph. Oh boy. What were our points again? Negative what? Negative what?
Negative 1.4.
Negative 1.4. And positive 0.4? Okay, so I guess this would be about 1. So I guess that's about 0.4. Okay. What else are we thinking about? Oh, I'm going to have to make the y-axis a smaller scale.
I know what you got.
Oh, yeah, okay. Blowing up here. Oh, what was our axis of symmetry? Okay, so 0.5 is about right here. Okay, what else do we need to write down? Negative 4.5. It doesn't look like it's the right scale, but you know, if I label it, that's what it is, even though it doesn't look like it's that far down. So that's my vertex, right? And anything else we'd like to put down? Well, there's a free point. What's the free point? Is it negative? Oh, yeah, it is. Yeah, good. I was going to make it up here. So I have to loop up. Yeah, no, that's good. Thank you. It's down here. It's a free point. Might as well use it at -3. So something like this. Boy, that's not pretty. Oh, well. Okay, I tried. So what happens when you don't have graph paper? Things get ugly. Oh, I can, yeah. Yeah, I can. Okay? Everybody feel okay about this? Any questions? Moving on? All right. Oh, that's not it. Second thing, simplify exponents. Oh, yeah. So, how do we handle the x's? How do we handle the y's? How do we handle the z's? I'll give you, 30 seconds or so.
30 seconds.
It's not that complicated. Just the first one, I mean, just the first one. You can do the second one too if you want. What's wrong? No.
I just went with it.
You just went with it. Okay. I still see people writing, so I'll wait. These are easy points if you know what to do. Okay, so I'm going to tell you what to do and then it'll be clear. Okay, so I say x squared times x to the 5th. They're both on top, right? So we just multiply. X squared times x to the 5th is x to the 7th. Because I add my exponents, right? When I multiply a common base, x times x, I just add their exponents. So x to the 7th. How about the y's? Same thing, because I have y, they're both on top. So I'm just multiplying y times y. I'm going to have y to the first power. That's right. I wouldn't have to write the 1, but there it is anyway. Okay, so the z is different. The z is on the bottom. That means I'm dividing. Since the z is on the bottom, I'm going to subtract the exponents. So I'm going to get z to the, it's going to be negative because I have 7, take away 15. So that's -8. And usually I like you to move things to the bottom if they're negative. So you should probably say x to the 7th y over z to the 8th. So when we do the subtraction, the answer is on top. I know there was a z on the top and there was a z on the bottom, but the result is on top. And it has a negative exponent, so really it belongs on the bottom. So I put it on top. And I changed the sign, man. Of course, once I move it, of course, I stop with the negative. Okay, so how about B? Special case. The only time you get to do this. All right, so since it's outside the parenthesis, that means I'm multiplying. So I get x to the 6th over y to the 10th. And that's it. I just multiply. It's the only time I get to multiply exponents. It's the only time I get to multiply exponents. And the two outside effects both things inside. Okay, so not bad, right? Okay, moving on. Number 3, complete the square. Oh yeah. Okay, so we're going to remove the number in front of x squared because we're not going to complete the square unless we get rid of that number that's leaving. It has to be a 1. So do that real quick. You can't complete the square with that 2 out there. Not going to happen. So we just divide by 2. What's our perfect number? Please find the perfect number. Do you know how to find the perfect number? The formula is b divided by 2 squared. So that's 6 divided by 2 squared, which is 3 squared, which is 9. My perfect number is 9. Okay, so I'm going to insert and solve. And I'm using this now. So go ahead and insert the perfect number and solve. Well, where would you like it to be? At the end of what? Well, we don't like the -3. I'll be honest with you, we don't like that -3. We wish it would leave and go away. Because it's not perfect. We may not be perfect, but we want something perfect with us. So. Yeah, that's a great idea. We sure would like to just replace that -3. Yep. And then we don't care. Go away, 3. Just go away.
So you just pick out a number.
Yeah, maybe to the other side.
That's coming.
Oh, okay. So we insert it, and let's see. We say, I'll do it up here. No, I want to put here. So we say x squared plus 6x plus the 9, because that 9 looks a lot better than that -3. And then -3 is still there. And since I put a 9 over here, I better put a 9 over here too. Because you can't just go around putting 9s for no reason. And then I don't want that 3 here, so I invite it to leave. and I get x squared plus 6x plus 9 is equal to 12. I don't really care what's on the right side. It used to be 0, now it's 12. That's fine, whatever. The main thing is I have a perfect square on the left side. That's the main thing. Okay, and then go ahead and solve. Lighten them up. Go ahead and solve. That means you're going to need to factor that perfect square. And lucky for you, you can still look back and see where you found your perfect number. That number inside the parentheses is your perfect. It's not your perfect number, but it's the number you need right now. The perfect number is 9, but before we got 9, remember what was inside the parentheses? Yeah, that's a good number for us right now. Okay, what do I mean? It's x plus 3 times x plus 3, right? Is equal to 12. All right, so I just factored the perfect square. I know it's the same thing twice because I built it to be like that. So that's why I said the 3 is a nice thing to remember because it helps me factor right away. Well, it would be equal to 0 except that I put a 9 over there and then I moved the 3 over there, so it's 12. So now it's not 0, now it's 12. And then I write it as a perfect square. And we still want to solve it, so we got to get the x by itself. Hopefully you're remembering that you're going to take the square root of both sides. This is the magic, where we make the x squared part go away. It's just x. That is super helpful to us. So that leaves us with x plus 3 is equal to plus or minus. I can simplify that, right? I guess I should. If I can, I guess I should. The square root of 12, there's a couple of 2's that will come out as 1. You know, yeah. So I simplified the square root of 12 into 2 times the square root of 3. And then I just moved the 3 over, right? And then I'm done. So x is equal to negative 3 plus or minus 2 square root of 3. Okay, somebody tell me what these numbers for x mean. What do these numbers mean? You got the right answer, but what do they mean, like x? Yeah. What do they mean on a graph? What points on the graph?
The x-point.
Thank you both. Yes, these are the same places that we found a minute ago with the quadratic formula, where it hits the x-axis. So we just did it a different way, but we still found out where it hit the x-axis. I wonder what we would do if we needed the axis of symmetry. We would add these together and divide by 2. Maybe we'd want to make up decimal numbers first, but it's the same problem, just done a different way. Okay? So if it seems like, you know, deja vu all over again, it is. Okay. Vertex form. So this is kind of variation of what we just did. I think I heard Sydney say she was going to do everything on the same side.
Absolutely.
Yeah, this is a good time for that.
Yes.
So same perfect number formula.
Vertex is the APK. Right?
Yeah, sure is. Mhm, sure.
That probably got lost in the
Well, yeah. Yeah,
Is there gonna be a curve? Please tell me there's a curve.
there's almost always a curve. I can't remember giving a test where I didn't have a curve.
Is that like real? Is that like sarcasm?
No, no, it's not sarcasm, it's
Thank
truth. Yes, I'm sorry? Oh, sure, sure. So y'all find the perfect number and you're gonna put it in.
I just realized symmetry doesn't do those.
You did, six, you got six? Or eight, that's eight. Oh,
Why
good,
not?
yeah, yes, you did, yeah, you put it in. Oh, we don't have another equal sign. So we're just- if we're gonna add, we're also gonna subtract.
Insert 16.
The equal sign is over here between us and the y. So just say
Insert the same thing we
minus.
did with 9.
Yeah, we have to add it and subtract it. Oh, yeah, you're thinking way ahead, good.
That's
Okay,
all I learned from what is that teacher's name in 8th grade?
okay, so we have 8/2 squared. That's gonna be 4 squared. My perfect number is 16, right? So I'm gonna put that in, I'm gonna say, x squared plus 8x plus 16, there's where I put it in, I wanted it to be there, minus 7, and then I'm on the same side because it's y equals all this, I already have an equal sign, I can't just say equals 0. So I'm also gonna subtract 16. Because again, this is a different way of handling the fact that I just put a 16 in. I also subtract it. It's like nothing happened. Yeah, and that's a justifiable question. That's like a good philosophical question, like why? Well, we want a perfect square, and there it is. So it's worth it to us. You
No,
know?
it's not.
Yeah, it's like if you don't have any coffee and you're like, oh, it's a long way to Dunkin' Donuts, but I think it's worth it. I need coffee and donuts. You know, so you're like, okay, I'm going. I'll walk. I don't care. Okay, so yes, we're adding a 16 and subtracting a 16. It seems like effort for no reason, but it's not for no reason. This is a perfect square. We factor it and we get x plus what? X plus 4 times x plus 4. And then, yes, we also have a negative 23. That's life. Sometimes they get your order wrong at Dunkin' Donuts and you just live with it. So we have a negative 23. Okay. Oh, yeah, did they really? I just ordered black coffee, so it's hard to mess that up. So we have x plus 4 squared. Oh, by the way, y is equal all this stuff. The fact that y is over there is why we're doing it all on the same side, to keep y on one side and x on the other. So this is squared and minus 23. And we're like, hey, that's vertex form. That is vertex form. It is. Vertex form is y is equal to x, well, I shouldn't say plus, x minus h squared plus k. That's vertex form. I guess I should put a out here too. There's an a in front, but I don't have an a this time. So.
How do we find A? A would be.
A is 1 this time.
So whatever is in the original equation would be A in the vertex.
No, not necessarily. No, it wouldn't probably be. I'd move it over. I might actually mess with y just for that, to get it over there. I didn't want to give you one like that, because that's more complicated. So don't worry about that. No, I'm going to keep A1 for this problem. Because I don't want you to have to stress about getting rid of that. On the test, I mean, I'm not going to do that. It'll be like this. Okay. So let's see. I feel like I said solve, but I think I'm gonna, yeah, I'm gonna get rid of that idea. I don't know what I was thinking. I'm not solving for X. I just want it to look like it's in vertex form. So I'm reporting the vertex. What's the vertex? Oh, it's almost as if X lies. That's what they were saying. Somebody.
X is pretty easy.
Oh, okay. Well, all right. We have to remember it somehow. So yes, the vertex, just by looking, is -4, -23. Everybody see why the vertex is that?
So why is it that?
Because X lies, it's telling you +4, and you're like, I'm not believing X, so you put -4. And you look over here at the leftover -23, that's the Y value.
So why?
Because Y doesn't lie to me, not in algebra 2. I'm sorry? Well, it's complicated, but yeah. I tell you that X lies just so you can remember that something's up. Because otherwise you're gonna look at that and say +4 and write +4. And you need to remember that X is psychotic, okay? I'm sorry? Yes, he always
He's a
does.
habitual liar.
He really is, he always does, and he
Cannot stop
fools,
lying.
he fools a lot of people, so I'm trying to warn you, don't let him fool you.
We're talking about H, right? Not X.
We're talking about X, because it's about X.
Wait a minute. X is X. Like, there's no number.
Okay, so the real reason is because we're looking for the 0. And what goes with the +4, -4 goes to make 0.
Yeah.
That's the real reason. X has a good reason for lying, I guess. I don't know. You have to examine him and see what you think. Yeah. So, is this a minimum or a maximum?
No,
This A that we were kind of referring to, it's positive, right? So it's a minimum. Because it opens up.
Oh, yeah.
And so that means there's a valley. So we have a minimum. And the minimum is at where?
The vertex.
-23 is right. There's a minimum at -23. Whatever the vertex Y value is, that's where the minimum is, right? It's the bottom of the trough. It's the low point in the valley. Okay? And the domain, yeah, I don't think I've ever given you a problem where the domain wasn't all real numbers. It's gonna change, but right now, it's pretty safe bet. And the range, what's the range? Can you picture the parabola in your head? It comes down at -4, -23. Yeah. Well, here's -4, and here's -23, and we're down here. Okay, so the range is all the allowable Y values. The Y values that will happen based on whatever I put in for X, which is anything. So what's Y allowed to do? That's my range. What's the lowest it could be? And -23 is included, right? So bracket. And what's the biggest it could be? I mean, it goes up forever. I've never been there, but I think it keeps going. We always start with the lowest value and we end with the highest.
A bracket then?
A bracket because -23 is included, parenthesis because I can't include infinity. Because I've never been there. And I don't know where it ends. As far as I know, it doesn't. I mean, I'm 52, I'm working on it, but I'm not there yet. I'll let you know if I ever get to infinity. You might lose a point. Because you need to understand that the bracket means that -23 is included. It's on the graph, right? Well, if I'm giving partial credit, you get some for this and not some for that. Well, I'll see how it goes. The conjugates, to remove the I from the denominator. Do you remember that?
Are you talking about Spanish class?
No, not like that. We're not conjugating a verb, but, you know, amo, I can't do it anymore. Amo, amas, amam, amamus, amam. I can't do it. They're Latin. I love, you love, he, she, it loves, they love, you all love, they, I don't remember. We, I forgot we. Oh, well, whatever. Yeah, I can't do it. I used to be able to. Okay. So what's the conjugate?
Oh, 7 plus 4.
Thank you for using a different sign. So if you like FOIL, you can do FOIL. Or if you just want to do first one times both, second one times both, that also works.
For which one?
For both of them.
You can do both of them?
You can FOIL or you can say. Yeah, we have to do it. Whatever you do to the bottom, we have to do to the top. So I wanted to do it on the bottom. I have to do it on the top since I did it down there. I have to keep things balanced, right? Fixing stuff. I thought I heard people clanking around. Just my imagination.
The bottom, where the eyes cancel out.
In the middle terms cancel. When I multiply by a conjugate, the middle terms always cancel.
So I got 28i minus 28. So that was
Yeah, I don't even bother writing them, to tell you the truth.
We just do the first one and the last one.
Uh-huh.
I thought the line is negative, should go, ones on the side also be positive.
Doesn't also make sense.
The ones on the side.
Sorry, I'm not saying this right.
The middle terms?
Yeah.
The middle terms will be different signs, right?
Like on the bottom, like for, I think on the bottom one it's negative, but then on the
So
side,
that's,
it's now negative, it's now positive.
So the bottom one is 49 plus 16.
All right, let's just, I'll just do it and we'll see what you're talking about.
Sorry, I'm probably not explaining it right.
It's fine. Okay, so that's what you should get on the bottom. I don't usually write the middle terms because they always cancel. They always cancel for the bottom. If I'm multiplying by the conjugate, I shouldn't get middle terms because they should cancel each other out. So I never write them because why bother? They always cancel.
Can you do the same for the top?
No, the top is not the conjugate of the top. So since they're not conjugates, you got to do the whole thing.
You just add or
You got to say 21 plus 12i plus 14i plus 8i squared. Okay. No, really? You don't know how to FOIL? Or
it's
just,
like, I know how to work,
okay, do you understand that I said 3 times 7 is 21? Right?
Yeah.
This first one times this first one is 21. This first one times this last one is 12i, right? I treat I like it's x, 12i.
Wait, why? Are we gonna be able to use this on the test?
Sure.
Why did you swear?
Yes.
We are?
Yes.
Oh,
There's no,
sir, why did you swear when you did the 12 on?
Well, because I only have 3 times 4i. Only the 4 has an i, so I don't have I times i.
Okay.
There's only one I. And 2i times 7 is 14i. Again, only one I. And then 2i times 4i. Now it's I times I. Now I get a square. But I also have 8. 2 times 4 is 8. The 14, oh, that was the 2, the inside times the third.
Oh, okay.
This, so 2i times, yeah. Now, you can also say 3 times 7, 3 times 4, 2, I guess I did, 4 basically works out.
So is that like 48 eyes on the third, on the bottom?
Yeah, they're both 28 i's. These guys are conjugates, right? Do you see that they're conjugates, 7 minus 4i and 7 plus 4i? That means the middle terms will always cancel. So to be honest with you, I almost never write them down because I know they're going to cancel, so why would I bother?
Where are we getting this negative?
Okay, -4 times positive 4
Okay.
is -16. I times I is I squared. That second term on the bottom will always be negative because the conjugates are always different signs, so it's always negative. Okay, now the last part, the i's need to go together on the top, and I can't leave I squareds hanging around. Okay? So I'm going to put these i's together because they're the same, and I'm going to get rid of that I squared, and I'm going to get rid of that I squared. Do you know how I get rid of I squared? I change the sign and I make it go away. Okay? So I get rid of this, and I'm going to change that sign. And I get rid of this, and I change that sign. Okay? This is what I always do for I squared. So what does that leave me with? It leaves me with 21 plus 26i, minus 8 over 49 plus 16. Okay, so I put the i's together, 26i, and I changed the two I squared terms. The last thing on the top, last thing on the bottom, I changed both signs because I got rid of the I squared. The I squared just left. But first it changed the sign. Okay, then I'm going to clean that up. 21 take away 8 is 13, plus the 26i still. And on the bottom, 65, is it?
Yeah.
Okay. I don't trust myself suddenly. Okay, good.
Could you simplify it by dividing them all by 13?
I'm sorry, what?
Could you simplify it by dividing them all by 13?
Yeah, hey, good call.
Yeah.
Is 13
No.
a factor of,
Yeah.
is it? Yeah, it is. Good, so I could simplify it, yeah. Let's see, it's 13 times 5, right? 13 times 5. Good, good. So I guess I could say 1 plus 2i over 5. That's even better.
Would you take both answers or just the simple?
Yeah, I'd probably take the first one. Because, you know, who factors by 13? Not people.
Max.
Yeah, good job. Good job. Once it goes over 10, I start getting a little bit. I should have.
Lazy.
I should have. Yeah, I can say it. The German people I grew up with are not happy about that. Okay, I'm not German, but I grew up around a lot of mean, angry, hardworking Germans.
Mean, angry, hardworking.
Yeah, don't think that they're not.
What type of personality do you have?
Well, we had a lot of Nazi POWs from World War II that were like, I don't know why they brought them to America, but they did, and they made them work on farms. And then some of them were like, oh, we're staying. This is great. We like it here. And they married American girls. And, you know, they didn't want to fight for Hitler anyway. So, yeah. All right, so let's see. Find a linear expression, y equals mx plus b. So blast from the pen, quarter 1.
Oh, good.
Find the slope. Can you find the slope?
It's
Change in y. I chose the second one as the second point. You can do it differently if you want. Okay, so everybody have the slope. Next, I want you to substitute in one of these values of x and y. You have two choices. You either have x of 1, y sub 1, that point, or that point. Pick your point, doesn't matter which one you pick, whichever one you think is easier. And plug it into y equals mx plus b with the slope that we just found. And solve for b. I chose the smaller numbers. I chose the first one. Everybody see what I did? I plugged in y equals 1 and x equals -2. And I plugged in the slope is 3. The only thing I don't know is that it is b. B must be 7. Okay, so then report the equation for all x and y. Not when x is -2 and y is 1, but for all of the x's and all the y's. In other words, okay, so if you can do that, you'll be fine. You ever see cat bug? Anybody watch cat bug?
What is that about?
Cat bug is a little ladybug looking thing that says, it's a little boy, I think, that does the voice. And he says, everything's gonna be, oh.
This guy?
Yes. And he has this little, it almost sounds like a girl, but it's a little boy. And he says, everything's gonna be okay. And it's not. It's not.
Everything is gonna be fine.
Yeah, that's the fun part. You know it's not gonna be fun. Okay,
So I'm guessing the next question is not going to be fun.
let's see, synthetic substitution. Oh, yeah, good. Okay.
Oh.
So set up synthetic substitution. We've been doing this here lately, and we did it longer than I thought we had been doing it. So I thought, okay, we'll put it on the midterm.
No.
It's not new. It's not new. So I thought, it's okay. It'll be good. I didn't skip anything. I should have skipped something. Did I skip something?
Yeah.
Oh, wait, ask him on the order.
Yeah, that's true. I did say the wrong thing. I was gonna do it wrong too.
Wait, really? What?
I think. Well, I didn't think I skipped it.
$1.
You sure?
I'll take it if he doesn't want it. I wasn't actually expecting you to give me the $1, but thank you.
It's like the sword once it comes out of the sheath.
I didn't think that was gonna work, honestly. I thought you were just gonna take the $1 back.
Okay, so let's see. I say 3 and 1 and 3 and the thing that I was not seeing, even though I wrote this stupid thing. There's a 0 where the x to the third should be -1 plus 2 minus 7. I'm using the coefficients. No, you don't like that? Do you see that there's a 1 out here? That's where I got that 1. There's a 3 here, and that's where I got the 3. They skipped x to the third, so I have to leave a memorial for the thing they skipped. It's a 0. There's a -1 in front of x squared, so -1. 2, 2, -7, 7. So I just wrote down all the coefficients. That's all I do. And if they skip one, I have to put a 0. Okay? First thing we do is bring down the 1. And make sure that you keep your columns neat, and that you leave enough room to write big numbers in case they're big numbers. If you squish them all together, then you have to line up these thousands, underneath real tiny columns. Sorry. Did you? Okay, so 3 times 1 is 3, and we add them, 6. Everybody see what I did so far? I multiplied the 3's together and wrote this. Wait a minute. I didn't multiply the 3's together. I multiplied the 3 times 1.
Yeah.
And I wrote it here. And then I added the 3's together. So I got 6. What am I going to do with the 6? I'm going back to the 3. 3 times 6 is 18. Plus 0 is 18. 3 times 18 is 54. Plus -1 is 53. 3 times 53 is 159? No.
Yeah.
Is it? Okay. 161. 161 times 3 is 483. No. 483. It is?
It's 40.
Okay. Because 16 times 3 is 48, so 480 plus 3. And then minus, I'm going to get 476. Okay. So if I were to plug in 3 into that polynomial, it would pop out 476. But I think this is easier than plugging in the 3 to that thing.
If you wanted this, like, when you had questions like code, this would have been so much easier.
Yeah. Yeah.
Drop the quadratic formula and stuff, Give us an x and it would have been so much easier.
Okay, so I was thinking about having an ACB problem on the test.
No.
What is
How
that?
many questions?
What's ACB method?
This would be A if I had this. I don't know if I'm gonna have A or not.
You should just make.
You think? You like ACB?
I don't even know. I like having more questions to that way.
Oh, yeah. What's 12 times 22?
And like, 12 times
264. Factors of 264.
Yeah, add up to
That add up to -17. I'm sure.
Sir, are you kidding me?
Well, it's kind of a weird one, isn't it? This is just for demonstration purposes. I wouldn't put a problem like this on the.
Oh, like demo purposes.
Yeah, I wouldn't do
For a
this.
demo, you would put something this hard, okay.
I wouldn't do that. Did you try 4? What's 4? Is 4 going to 264? So you pick up your calculator and you're like, 4. So 4 and 66? Okay, so
That's still real.
so 4 times 66 is 264, and that would give me -62, so no. How about the 6 do it? The 6 going evenly? Oh, okay, 6 and 44. So that's -38, not yet. How about 12? Oh, no, 12 wouldn't go into it. 22? Well, I know the big number has to be negative because I get -17. Oh, yes.
This is messed up, this question is not right.
Yeah,
This question is messed
you're
up.
right. They both have to be negative.
No.
Okay, so, yep, you're right.
This could actually don't.
So that's 70.
This actually don't.
So who called me on that? You did? Oh, good, good. I have some quarters in my desk. Let's see. Oh, I need that.
I like to feel prepared with the money, you know? Got spirit quarters sitting around.
What? Let's see. 34. Okay, so I'm further off than I thought I was.
14?
Is 16 a choice? Is that? Oh, we don't get it. Okay. 18 is 18. Absolutely. How about 20? 20 is not. 22 is. Well, that's 12. Did I mess up on this one?
Yeah, I don't think this is gonna work. At this point, you should just give up.
No real numbers.
Unidentified.
A bunch of
Sir, you made
It's imaginary number.
I don't know.
Square root of
So
2.56.
so what I'm saying then is maybe I thought I was gonna have a plus and a minus, and I found it on that basis. And then it's not.
Did you create this or was this?
I just made it up. I thought I made it up well, but maybe I didn't. 12, negative 17, 22.
So there's something complicated. I hate it. Where's that one? 12x squared minus 17x plus 22. Ooh. Amazing.
Oh, it doesn't hit. I made one that can't happen.
It hit something.
That's great. So what did I do wrong?
You put a 22.
I should have made it negative. I should have made it negative 22, I guess.
Or 30% point.
I must have written it down wrong. Okay. So there is no answer to that. Sorry about that.
Oh, sir, are you collecting this? No.
No, you keep it and study it and you're good.
Yeah.
Oh, yeah, if you want it. Because I don't mind if you stay for this one.
So that's everything I put it.
Yes.
It should be like the same.
Oh, the fingers. That would be a surprise, wouldn't it?
It would be easy grading for you, so you don't have to grade.
Is this from last time? Okay.
Give us a trick question that has no answer on the test.
Oh,
Where
boy.
we ask you to get
Just so you can watch us stress out over it the entire time.
That would be evil.
No, that would be cool.
You
That'd be
think?
great.
I don't think that would be cool at all.
Wait, what's the? No, wait. Yeah, that would be
It'd be
great.
a little
No, I
funny.
don't have a test.
You think so?
I hate myself afterwards. I think it's a little funny. I sit there being stuck on that question for 20 minutes and I go, the trick question, and then I move on.
Oh, boy. Seems bad.
Sounds fun. I don't know what you mean.
Oh, man. I saw a comic strip one time where every answer was B. And they were all like slamming there.
Are you doing that thing? Remember when you like wrote it down and then you didn't know it, I like credit. Are you doing that?
Do you have really nice notes?
I have horrible
I can use some extra
discussion.
credit. Do you want to see them? Me too.
I never take notes in class.
Maybe I'll look at them next week. Oh, yeah. Thanks. I'm sorry.
You feel like
You can still turn it into that. Before the strike of midnight.
Hey, send me a copy of it.
That is impressive.
Send me a
No
copy of
doubt
it.
about it.
Please.
So.
Photocopy it.
Nice. It's on my desk.
I did it last night until 1:30.
Wow. It's on my desk somewhere?
Yeah, put it right there.
Oh,
4 papers.
okay. Good deal. Oh, it's from December. Uh-oh, December. See, there's this thing, I take work from January, but not December.
You should just let it slide.
Interesting.
You should just slide it under the January
Oh,
papers
yeah.
and just say it's from January. change the date.
You think so?
Pretend the dates don't exist.
Exactly,
Ah.
don't look at the date.
There's no date.
Just give her a solid 100 for not signing anyone.
Interesting. Interesting how you guys think.
Or give her like a.
You said about 1:30 in the morning doing it, so.
I'm sorry?
You know, she said like 1:30 doing it, so I mean like,
I know, right?
2 points.
She was gonna stay up anyway. She didn't play the game.
You know what? I understand your point.
Not me, I don't write.
Some people, they step and then they keep going.
Right.
Yeah, if I was able to, I'd be like, you know what? I'm pulling an all-nighter constantly. My
Well-
mom comes into my room and checks on me and goes, you better be sleeping.
The good thing is that she's now ready for the midterm, like she wasn't before. So that's good.
Preparation.
Yeah.